Hello, and welcome to another day of the project. And I can feel that this will be taking a long time to do, especially with the pace of 1 to almost, no, not almost to even, to 130 hour per day. And yes, I discovered any new stuff that I need to also research on top of the things that we have already listed here from yesterday. So it will be more like learning and less of actually building. You can only build after you get used to everything here. And another thing, I think I'll drop the user part for now. I'll keep it here, I'll not delete it, but I'll not be working with it right now, because I think the user will be added only when we have the authentication process first. So less focused on user and I'll be more focused on the tasks. And then I had the idea, do we have too many rows, or sorry, columns in the task table that we did? We have the ID is completed, date, tags, title, description. I feel like the last three can be separated to another one, but I'm not sure. I'll keep it like this for now, and we will see how it goes. So back to our to-do list. What do we have here? Search for the type. What type of sequence is suitable for my project? Yes, I wanted to ask about that. In Spring Boot, what do you call it? JPA or no? In the creation of an entity, how do we pick which sequence to use in the strategy or mapping? So auto is the default. Now we'll probably be typing what is the numeric? Let's just number everything here. Yes, better. Instead of making it manually. Because I do plan on writing the answer of all my questions here. So by default it's generated auto, which selects the most appropriate strategy for the database hopper. I guess we have to start by defining what even is a generated value. Explain to me the generated value function and generation type. Before choosing the type, you have to understand what type, what does even type mean to begin with. In Java, the generated value annotation is used to specify how the value of entity primary key will be automatically generated by persistent provided by Hibernate when a new record is inserted. So yes, okay, everything makes a key, but they differ by the way they make the key. Add generated value annotation applied to a field. Then yes, you pick a strategy. Specific strategy is used to use the primary key. The generator is optional, forget about it. Now the strategy generation type, okay, it's an enum. Okay, I have to memorize now that every time I see all caps in the code, it's probably because of an the strategy attribute of generated value is used to specify the key generation strategy. This is where the generation type enum comes into play. The generation type enum defines 4 different strategies. So you have the auto. For example, this default option works well if you are agnostic about the specific database and want GPE to figure out the best approach for you. In most cases, it will use an auto increment field in a database like MySQL, but might use sequence like database in like PostgreSQL or Oracle. Still doesn't explain what auto necessarily mean, but okay. It's responsible for generating the primary key value, typically by auto incrementing the column. Example, this is the most common strategy for database that support increment columns. MySQL SQL Server. When a new entity is saved, the data will generate a new key value for the primary key. Okay. A sequence is a database object that generates series of unique numbers. Example, this strategy is often used with a database like Postgres. Okay, I have to specify what's the difference between all the strategies and what else? When to use a specific one. Auto, identity, and table is providing the same answer from before. Which is not helpful to begin with. Okay, because he only keeps on giving the definition, not necessarily what when to use which. All databases, MySQL, Postgres sequence. Let's just say if we want to avoid the old databases, so that will exclude 1 and 4, which will leave us with 2 and 3. Okay, let's research. Hibernate. What was it called again? Generated values. Generated strategy.
Database features like auto-incremented columns or hi, welcome back. In previous lecture, we have seen how to use JPA annotations to customize the table structure, right? In this lecture, we'll see 4 types of JPA provided primary key generation strategies. Well, basically, JPA specification supports 4 different primary key generation strategies that generate the primary key values programmatically or use database features like auto-incremented columns or sequences. Okay? And here are the 4 primary key generation strategies like auto, identity, sequence, and table. Let's discuss each of these primary key generation strategies one by one. Well, let's first take a look into generation type auto.
Sequence probably the most complicated one that I did before.
And it lets the persistence provider choose the generation strategy. Well, whenever we specify generation type as auto, then this value will let the persistence provider or the database vendor to choose the generation strategy. Okay, and in order to specify generation type auto, we have to use at generated value annotation. So you can see here code snippet. We are using at generated value annotation, and it has the attribute strategy, and we can specify generation type auto as a value to the strategy attribute. Okay, and if you are using Hibernate as a JPA implementation or the JPA persistence provider, then Hibernate will basically select the generation type based on the database specific dialect. Well, most of the popular relational databases like PostgreSQL database, Oracle database, MySQL database, so these databases use sequences to generate primary keys for the tables, right? So Hibernate will basically use or select the primary key generation strategy based on the database specific directory.
Based on the database itself. Okay. How is the auto function? Not necessarily function. Is selected if it's based on the database. What's the difference? I wish there was a button that I can press that reads all of this. When you use generated type in auto, the system provider automatically selects the most appropriate strategy based on the database dialect by examining the specific database. Okay, how does it work? To choose the best strategy based on the database you're working with, and decide whether to auto increment, sequence, or. But still, if we are using auto, and auto is the one that we are using in increment, it doesn't make sense. Auto is how we'll check the database dialect and select the appropriate strategy. Auto increment common MySQL, SQLite, and SQL Server. Okay, so this one will be an identity. Okay. What about the other ones? We have for Postgres and Oracle, they will use sequence. And if it's a native support, we'll say it's table. So auto is a way to pick from the other three options available. So if it's auto, it will pick either table, sequence, identity. Is that correct so far? But how does auto to begin with work? The best strategy, key generation based on the database you're working with. The system will inspect the underlying database inside to use auto, increment, sequence, or table based. So what do you mean exactly by auto increment, and how will the program, not the program, how will Hibernate decide if it should use it or sequence and tables, for example? The feature provided by many relational database that automatically generates unique numeric values for a column each time a new row is inserted to a table. These values will increment automatically based on the database each time a new row is inserted. It's typically used for generating sequential 1, 2, 3. Okay, so that's what he means by auto increment. But that creates the issue if there is one column that's deleted, it will also be deleted and the continuation will start from that point. So you can have some weird cases like 1, 4, 7, and they are in order. So we have something called auto increment, sequence, table, forgot the fourth one. One Hibernate use increment, auto increment. Identity. Okay. detects the underlying database, supports auto increment. It will choose when you use generation type auto in JPA and Hibernate, detects the underlying database, supports auto increment. It will choose generation type identity as the strategy for generating primary keys. When Hibernate choose auto increment, so auto increment is identity. I thought they were separate terms, but apparently not. The column is defined with auto increment property in the database schema. No, that doesn't make sense. What are the 4 types of is it called generation type, or I think yes, strategy. So we have auto, identity, sequence, and table. When to use each one of them? Give me a real life scenario. So just to not keep on scrolling every 5 seconds, I will take this because I will forget them for sure. So these are the type: auto, identity, sequence, table. I think that these 3 are understood. The issue is with the first one. What does auto mean? Auto to what exactly? Imagine you're working on a project and where your application might need to support different databases, SQL in production and Postgres in testing. You want to ensure that the application works seamlessly on all these databases without having to manually manage the primary key generation strategy based on the database. When you use generation auto, it's the most flexible strategy. It allows Hibernate to automatically pick the best strategy based on the underlying database. It makes your application database agnostic, allowing you to support multiple databases with minimal configuration changes. Okay, I see. So auto will pick based on what database we have, and that's why it's called for everyone. And the table will be based on if we didn't use one of the mentioned databases. The second one will be for MySQL. The third one will be for Postgres and Oracle. Okay. Developing a SaaS service that will be deployed across multiple client environments. Some clients use MySQL, others use Postgres. Will identify for MySQL sequence, for Postgres sequence, and for a table for H2. Okay, identity is MySQL. Here we say MySQL. And sequence, I know that one to be, yes, Postgres. Okay, so that settles the debate with the auto. Identity with auto increment. You are developing a simple web application for a startup that will use MySQL database to manage user records, and you want to take advantage of MySQL built-in auto increment feature to automatically generate unique primary keys for each user. Why use identity? MySQL supports auto increment columns, so Generation type identity is the most efficient way to generate unique primary key automatically. With this strategy, you don't need to worry about sequence or managing custom key generation, but that goes for everyone, for every database basically. As internal system to manage customer data since they are using MySQL database, will efficiently identify primary key. Okay. So there is no real big difference between the strategies outside of the database that you are using. There's a significant role. Key generation mechanism. Auto increment relies on auto increment columns managed by the database. The key is generated after the row is inserted. This can have performance impact when multiple inserts are happening concurrently as the ID is generated in the insert. In the database, the key before the insertion operation, this generates faster and more efficient for concurrent insert, especially in databases like Postgres or Docker. Okay. Table to stimulate key generation. This is slow because it requires an additional table lookup and update on every insert. But, so technically we only have 3. The auto one will just pick one of them. Not sure why we have the green here, but sure. So what's the difference between each one of these? Have the sequence, auto increment, aka identity, okay, this one adds before insertion or after. After the row is inserted. The key is generated after the insertion. The key is generated before the insertion. How does this affect actually? Relies on auto increment managed by database, generated after the row is inserted. This one is before. To simulate key generation. This is slower because it requires additional table lookup and update on every insert. This strategy is typically used when auto increment and SQL are not available or feasible. Okay, so this one right here uses a table to make a key, whatever that means, but we will check that in a second. Maybe I should just make this a bit bigger. These are the key differences, so I'll keep them like that. Now, what else? Yes. Apparently there is more. Let me just eyeball them real quick. performance. You can create performance bottleneck in high occurrence environment to retrieve the key before the insertion. Concurrency. Uniqueness. I will get to these again, but let me understand. How does adding the key, not necessarily the ID, before or after the row insertion affect our efficiency and code? Because I understood, okay, now that's the difference. But why does this difference matter? The timing of when a primary key is generated before or after the affects both efficiency and complexity of your code, particularly in terms of performance or concurrency and application logic. Okay, we will start by the sequence generated before the actual insertion. Example, the primary key is generated by the sequence before the insert statement, and the generated value include in the insert statement. Yeah, we understand. How does this affect efficiency? Sequence. Concurrency. More efficient in high concurrent environment where the key is generated before the insertion. Multiple threads or transactions can generate keys simultaneously without locking conflicts. Okay, so you can have multiple users working at the same time. Not sure how that became a thing, but we will see. Since the primary key is ready before the row inserted, the database doesn't need to go back and update the record after the insertion. This can reduce the number of database round trips. Key generation before is more suitable for global uniqueness and scaling, since sequence can handle a concurrent insert. I understand. Performance benefit. Highly concurrent application where many transactions are inserting new rows. Now for the identity. Can create performance bottlenecks under high concurrency since the key is generated after the insert. It can create conflicts, especially in highly concurrent environments where multiple inserts, so it's not good. When the key is generated after the insert, that's a lot of reading. I need some water for that. Because that begs another question. When to use which database, whether it's Oracle or Postgres or whatever we have here, because it mainly, from what I see, at least from the ID point of view and keys, it does matter. The key is generated after the insert. The database needs to insert the row first, then retrieve the auto-generated key. This can be less efficient in high volume of environment, especially when you need to retrieve the key for using. Now with the code complexity, available immediately after the entity creation, since it's pre-generated, you don't need to worry about fetching the ID after the insert. No need for additional queries. I mean, it looks like I'm reading that Postgres is basically more efficient and better than MySQL. Okay, that entire table is probably the best summary. Doesn't that by default make Postgres sequence based generation better than identity? If not, okay, let's just start with that question first. However, while sequence often have performance advantage, they are not necessarily universally better. The right choice depends on the specific requirements of your application, the database system you're using, and the nature of your workload. Let's break down the sequence can be better in why sequence-based generation is often better. Sequence allow concurrent key generation without the locking or contention. In databases like Postgres, sequence are designed to be highly concurrent, meaning many transactions can request new keys at the same time without blocking each other. This is because, okay, that's a positive then. After the insertion, this requires database to lock on a row, resulting in performance bottlenecks in highly concurrent. Okay, he's repeating what he just said. When identity based simplicity, it is very simple to use and doesn't require an additional setup beyond configuring the primary key. Simplicity isn't, it's not a reason to just pick something. Sequence require explicit configuration in your entity or directly in the database. Okay, that's also not a negative. When database performance is optimized for identity. Some databases like MySQL or SQL Server are optimized for auto increment or identity columns. Okay, now I'm getting confused again. Auto increment is identity, or is there a difference? Is there a difference between the two? I don't think so. I wouldn't say it's more efficient, it's just simpler. Small scale application. For a small application with low occurrency and low traffic, the performance difference is often negligible. Yes, of course. Compatibility with database feature. Okay, ChatGPT is not giving me any useful. Okay, so it is different. Auto increment is not identity. I probably need Google here. What's the difference between ID or primary key generation strategy? Again, I'm not getting the answer that I'm reading. And this guy is saying we have 5, not just 4. Still can't seem to find the answer that I am looking for. In any distribution system, one of the primary problem statement every engineer faces is the ID generation for an entity. Too much reading without any real answer really to my question. When do we use which? Okay. This will drive me crazy. Give me a real difference between the strategy so I know what is suitable for my project. Yes, what? Explain this sentence. Blog concurrency. Imagine a simple application like a blog or a task management where data insertion isn't a high-through operation and you are working with a single database. Each time you insert a record, a primary key will automatically be generated when to use. When you are using a single relational database system, your project does not require high concurrency. You prefer simpler implementation. Again, simpler is very subjective. Is used to generate high concurrence, so multiple users at the same time. Social media platform or financial service that handles thousands of operations, which seems like, yeah, the normal stuff that you will do. But again, what is the advantages of, okay, let me write this scenario. So imagine this scenario. Let's say I have a blog website. It should, okay, according to your explanation, the choice is identity based strategy. But what will happen if I did it with a sequence instead? What will be the advantages and disadvantages? We have been over this question, I think, for over 30 minutes now. Is it that complicated to get that question? I don't think so. Let's dive into the scenario where you have blog a website and you're considering using the primary key. You have a blog website. Every blog needs an ID. You consider two options for primary key. Yeah, I mean, that's technically the only two options we have. It's either identity or sequence. The last one, table, is you only use it when you don't have the other two available. We will get to the table part later, but when you configure Hibernate and sequence for a primary key, a sequence generation is used to generate unique advantage of using centralized ID generation means that the database is responsible for generating a unique ID. The sequence is a database object and it guarantees unique ID across the entire application, which is useful if you scale up to multiple database servers or if you have replicate database in the future. Predictability and customization, global uniqueness, faster ID access. Disadvantage: extra database or overhead. Sequences are typically slower than auto increment columns for a single law inserts because the database has to make a call to the sequence generator each time a new row is inserted. For a blog website with a relatively low traffic, this extra overhead is likely to be negligible, but for high throughput performance, the performance impact could be more noticeable. No guarantee of sequential order in the database. In a sequence-based generation, The IDs might not be subsequential in the database due to concurrency and the way sequence are implemented. For example, if you generate an ID and then another thread generates an ID, in order for the IDs in the database might not be exactly sequential, even though the sequence itself is incrementing. This could make your primary key IDs look disjointed or non-contagious in some way. That not all database support sequence. Okay, forget about that one. Potential caps in IDs. I think I get it, and I also don't get it at the same time. A lot of reading and a lot of filtering to do. Still, what's the real difference between the two though? Will it be easier for me to ask more specifically about MySQL and Postgres, for example? And which one is better for what task? Let's say, what happens if you stick to the, okay, let me just reread all of this because there are some parts that I want to make questions more about it. These are the advantages, so let's check the disadvantage. Extra database overhead. When you say sequence is typically slower, in what sense you mean by slower? Exactly. When you use a separate database operation is required to retrieve the next value of the sequence before the actual insert operation. Typically, this means the database needs query subject object to go to the next available my sequence. Once the ID is retrieved, the insertion occurs. So yes, it's two steps. You create the key first and you get it, and then you insert it. This requires two interactions with the database, one for fetching and the next sequence value, and one for insertion, which can add small amount of latency. Auto increment generation. With auto increment generation, the ID is automatically generated and incremented as part of the insert operation itself, meaning the ID generation and the insert option happen in one atomic step. So the auto increment takes two steps. The auto increment takes one step because it generates. I mean, you still have to add though. It's not considered two steps. Okay, let me read a bit more. Forget about the concurrency part. Let's say your blog website have high traffic scenario where 100 or 1,000 of blog posts are being created per minute. Created is something and viewing is something else. No, I still have more and more questions. So because the sequence need to create the key first before insertion, that takes two steps and is slower, but auto increment adds the value, or not add, insert the values first before adding the key later. Isn't that is still also two-step process. Explain to me how not how late, what exactly do you mean by latent? Step 1, generate the key before inserting. A separate round trip made query is made to fetch the next value from the sequence. The sequence ensures that every generated key is unique, and it's incremented automatically after every retrieval. Step 2, insert the row. So for the sequence, there are two distinct database interactions: fetching the next key from the sequence via select query and inserting the row. Compared to the auto increment, the row is inserted into the table, and at the moment of the insert, give me a second, the database automatically generates the primary key. This happens because the auto increment is a property ensures that the primary key is generated automatically as part of the insert statement. The retrieve the key after the row is inserted. Generated keys available for the application. The more I read, the more confused I get. I guess we will get a water break for now. Too much reading without any real answer, really. Okay, a better search term. Sequence versus auto increment. Okay, Stack Overflow. Don't completely understand the difference between Oracle sequence and MySQL's auto increment. There are some very significant difference between auto increment is tied to the column in a single table, only one per table. Oracle sequence is not. On a database restart for a data table, auto increment is reset to the highest column value. Oracle sequence is not. I still don't get it. Table, you simply don't mention the auto increment column. Okay, more confusion.
Hello, this is part 5, the differences between Oracle database and SQL Server database. In this session, we will see the differences between identity column and sequence. In Microsoft SQL Server, we are using identity column to increase the value, and it is a auto increase value. The same thing we are using in Oracle with the help of sequence. Let's understand what is auto increase value. In our example, we are using HRDB. So HR database having employees. So each employee having a unique employee ID to identify the employees. Now let's say the recent employee ID is 100. When a new employee after 100 is joining, no need HR has to go and check what is the previous employee ID. Instead of, they can set a identity column in Microsoft SQL Server, similarly sequence in Oracle, so that the database engine will remember the previous value and it will add by one or the specific value which we are providing in the identity field. So let's see an example how exactly this is working. So let's jump to Microsoft SQL Server. Now I will create a table called EMP with the three fields. One is employee
Still,
ID.
for some reason, I feel like nothing is going in my brain. Database auto increment, which one is right for you? How about instead of auto increment, we say INTT. Sequence identity versus similarity. I'm not sure what the fuck is that. Key strategy. GPA ID auto increment identity versus sequence. I am getting more confused, and my brain's just stopped working. Okay, give me a second. So let's revise what we did so far. So we understand that sequence is faster and more efficient at handling multiple calls at the same time compared to the identity, but the identity is simpler and can be faster, so it depends on the usage. So if you're making a blog website and it's just your blog and nothing else, there is no need to actually have multiple users creating something at the same time. Am I getting that correctly? The blog post is just a bad example, because you can have a blog about yourself and that's it, or you can have a website that creates blog for every single person. Yeah, my brain just stopped working. Giving me more of a headache just thinking about it. And there seem to be not really that much good videos about it. Okay, he is explaining the. Okay, let's maybe understand what the sequence is.
Let's go ahead and learn about the big serial data type. So, if you remember correctly, when we created both person and car tables, right here the ID is actually a big serial, so big serial. And if you remember correctly, I mentioned that big serial is a special data type which auto increments a number, right? And that number is an integer. So if I open up my terminal and if I describe both person and car, you can see that the type is actually big int, so there's no such type as big serial. But the special thing about it is that right here, so on this default column, you can see that it has this next val, and the next value is managed by this person ID sequence. The same for car, so you can see right here, so the type is big int, and the default value is this one right here, which is also managed by a sequence. So what I want you to do is to go ahead and select, so let's go ahead and select and then start from, and then we can actually select from both sequences. So let's go ahead and say person and then underscore ID and then sec for sequence, semicolon. If I clear the screen, now you can see that the last value is 3, and then the log count is pretty much how many times it's been invoked, and then right here you can see whether it's being called or not. So if I go ahead and select start from person,
okay, I don't think that's what we're searching for necessarily. Auto increment identity versus
Hello and
sequence.
welcome to this tutorial. In today's video, I will be demonstrating the most commonly used strategies for generating primary keys in GPA, namely identity and sequence. The GPA specification offers various methods to generate auto-incremented primary keys. By simply adding annotation to the entity identifier, you can achieve this. So understanding how these annotations work is crucial. Let's take a look at this example. In the Spring Boot project, I have defined an entity called employee with the following ID. First, we create a repository interface to handle GPE functionality for the entity. After that, we define a service that will contain our method. The method creates and persists entities in a loop, and it is annotated with transactional annotation to assure that the entire work happens in one transaction. Following that, we will create a REST controller to enable calling the method directly from the browser. And to see the interaction with the database, we will set this parameter to true. So at this way, the statements sent to the database will be logged. For this demonstration, I am using PostgreSQL database, but it could be any other database. So in our demo, the first test is done with this strategy identity. So all you need to do is to add this annotation generated value to your ID and see what happens in the database. So we can run the application and observe the log. Application has been started, and as you see here, this is the only statement sent to the database is to create the table, and the type of the ID is big serial. So let's see in the database how this information is interpreted. So this is our database. Let's open the console there. So what we can check in PostgreSQL is this view sequences. Why? Because column of this type big serial, PostgreSQL we
Select all from information theme
generate
sequence.
sequence for that dedicated to this column. It means that this sequence is associated with our table, and not only that, we can check here. We can check the columns, this view in Postgre, and as you see, the default value is retrieved from the sequence. This is very important. I will show you later why. So if you perform this statement, you don't need to specify ID. It is automatically filled. So let's check. And as you see, the ID has been automatically retrieved from the sequence.
The identity does the same thing.
In part, so I will show you later why. This entry point, let's test this method. So we are just creating, entities in a loop, and we save the entities in the database. So let's see in the logs what's happened. We can change here and call this method using this entry point defined in our REST control. So we can run this and check here. So it will wait here. Each time we persist an object, the query or the statement is sent to the database.
Mhm.
Hibernate or the GPA provider is doing that because the GPA has no access to the mechanism how this ID is generated. So GPA has to send this query. A round trip takes place to get the ID. So this is not very efficient. So I can show you the difference when using another strategy. So we have seen here that each time you persist one object, synchronization with the database takes place. This means round trip to the database, and this is very expensive. Now we will change this by using sequence instead. Let's rerun and check the log. So we restarted the application using sequence instead of identity, and as you see now, so the GPA provider has created the sequence to fill or to provide the IDs. So the GPA is aware of the existence of this sequence, and this is the table, and you see now it is big int instead of big serial, and this is very important. Let's see what happens when we call this method again. Let's have a look at the log, and as you see here, only values from the sequence has been retrieved, and the inserts will happen at the end. Look at, you see, so there is only 3 round trip to the database instead of 1 round trip to persist one object. So all those objects are
I think he's saying something good, but my brain is just, it's not working right now.
to this.
We'll save that video. But god damn it, my brain is not working anymore after all that research. So I thought we delved into it a bit, but we still don't understand the difference between these two after spending all that time with them. The only difference I know is one key is incremented before the call, which is the sequence, and the one is called after. I'm not sure how that is useful to begin with, but I think I'll just research it more a bit on my own after the streams. But But generally speaking, if we plan on using multiple different what is it called, strategies, it's a safe choice to pick auto, because auto will pick one of the other three. Forget about the last one. The fourth one is just completely useless. It's just very niche and very situational. It depends about certain stuff, but the main issue we have is between MySQL and Postgres, which is I think Oracle here. Oracle, and we have here more. I think it was called Server. I'm not sure, the Microsoft one. Okay. I think that will be it. I cannot continue for some reason. My brain is just not working. So I'll see you guys next time. Oh, my brain.